Okay, so let me show you what's going on here. This is the upright that we mounted to our 2-foot board. We have drilled the hole at the center point of this board, and right now we have the drill bit put in there, and I'll just explain why in a moment. Eventually what's going to happen is we're going to cut a hole in this board, and we're going to mount the ring holder to this board. And that's going to hold the copper ring, or copper ring you can see in here. And so it's eventually the shaft for the generator is going to go through the hole and contact the ring. So what we need on the left side of the board and on the right side of the board, on one side of the board is going to be the stepper motor mounter bracket, which is going to mount the stepper motor for driving the generator. On the other side of the board is going to be what we call the bearing assembly. And just to show you how the bearing assembly works, we're going to have a shaft of some sort. This is just an example of a brass rod with some skateboard bearings on it, or there's roller skate bearings, I don't know which ones. And I designed the bearing holder to be able to hold the bearings in that holder for the other side that would hold the other end of the shaft. One end goes into the stepper motor, the other end goes into the bearing holder. And the reason why there's two bearings is because we're going to put copper conductors on here, and we're going to take the signal off of the shaft using this little fixture here, which is going to have brass rods in it for being able to make contact with the bearing. Now, we're not going to use a conductive shaft, at least where the bearings are concerned. I'm just using this as an example. So what we need to do right now is we need to get these two things aligned so that the shaft for the generator is as straight as we can possibly get it. So what I've done is I've cut some 4-inch sections of 4-inch material called AZAC. I called it ANZAC before. This is a beautiful material. It machines very well. It's dimensionally accurate. It doesn't warp. It's used for trim. That's why it's a nice material. It's expensive, but it's a very good material. And these are exactly 3/4 of an inch thick here. And so what we're going to do is we're going to stack these up till we get close, and then we're going to shim the rest of the way. So how do we do this? Well, let me focus in on this over here, and we'll show you how we're going to do one side. So what I have in there is I have the 16-inch drill bit. And this device here, this is what I call the alignment plate. And the alignment plate fits over the drill bit. And you put it up flush against. And this is going to be used to align all the 3 parts. And then what we're going to do then is we're going to build up some AZAC. And then we're going to put in the holder. I hope you can see it in the detail with the lights. Let me zoom in a little. That this little outer ring here fits exactly into the hole of the stepper motor bracket. And then you see we have a little gap down here. What we're going to do is we're going to use playing cards to measure to find out how many playing cards we need to get that gap just perfect. So this thing is resting in there very accurately, and there we have it. Then what we do is we take this off, and we measure this with our calipers, and this value came to 0.3, I think 0.3. I measured it before. I did it a little more accurately before. I did it slowly. I'm trying to do it quickly for the camera. And this is the 3D printed spacer that was made. And now we can fit that, and that's going to be our stack up to get the stepper motor at the correct height for the shaft to be perfectly aligned. Then what we're going to do, we're going to pull this aside, put that stack up off to the side, and then get some more AZAC. And you can see this guy, he's designed to fit perfectly. Let me zoom in so you can see. He's designed to fit perfectly around that large, long protrusion there. And in fact, just for reference purposes, I made this hole fit exactly the bearings so that, you know, you could get a nice, good fit there if you need to. We don't really need the bearing one. And anyway, to save time, so I made the spacer for this. And there we have a nice fit. So that's how now we got the stack up to the right height. Okay, so what we're going to do next is you take your blocks of AZAC and you can use this to line them up nice and get them nice and perfect. And then we're going to put a clamp on this packet, hold them together, and then on opposite corners on one side, I'm going to countersink and put drywall screws through that go through most of the way, and then I'm going to flip it over, and the opposite corners do from the other side do the opposite corners. And that way they'll hold these blocks together real nice and keep the edges all lined up. And then what we'll do after that is reline them back up, and then we're going to put the appropriate spacer on them, make them so they're all nice and flush, and then we're going to screw on the whatever these things, I don't know what we call these, the mounts, whatever, the spacers and the mounts. Okay, so what we're going to do is we're going to mount our holders. So take your block and your spacer and your holder and put it up against the wall. Make sure it's flush. Okay, don't worry about it's not centered on the drill bit yet. We're not worried about that. Just make sure it's roughly centered on the block. Doesn't have to be perfect, but everything is up flush against the wall. Then make a little drill hole. I just did that a second ago. The camera wasn't on when I filmed it, so I didn't catch it. So I'll put the screw in again. So I already made a little hole there. Again, just double check, make sure everything's up flush. Okay, and then we put the other. Now, I broke my bit in a previous scene, and I don't feel like looking for another one. This stuff is pretty easy to drill through with a broken bit anyway. Now, let's put that screw in first. Sorry, you gotta reach to get a washer. Basically, if you get one screw in, it'll kind of hold it together from shifting while you drill the other holes. And again, the 3D printed material and the ANZAC or AZAC is not very, so don't crush it. It's strong enough to do what we need it to do, just don't crush it. Okay, the next part you're going to need are 10-inch sections of half-inch L-channel material, and this is made of aluminum. And what we're going to do is we're going to screw these to the floor to make rails so that we can slide the groups up, back, and forth to adjust for different armature types we may want to install. Now, what we're not going to do is we're not going to put this up against the face because we don't want to obstruct anything that might be rotating on the wheel. So this is going to be at least an inch, if not an inch and a half back from the surface here to allow for clearance for anything that may be rotating on the armature. Now, when we set this up, this now will be on this side. Once we set this up for this guy, then only this guy can be on this side. You can't swap it out with this guy. And then we're going to set this guy up on the other side using the exact same process. So what you do is you put the alignment wheel in the hole, and then you push this up so that it is engaging the surface and it is up nice and flush against the surface. Then what you do is you gently push this guy up to that location. Okay, and then what I'm going to temporarily do is lock it down just to hold it. Now I did this perfect off camera. It's just a tryout. Let's see if I can get it right on camera. Then what you're going to do is you're going to make yourself a little square using spare pieces of L channel, and you're going to adjust that square and adjust it so it's right up against and it's still there. Good. And then you're going to move it to the other side, and then you're going to adjust the length of the other side so it's exactly the same length from the L channel. Then you're going to put this side on and lock it down. Okay, then you're going to go back to the other side. Just make sure it hasn't changed. Oh, it changed a little bit. Hold on. Ah, damn it, just dropped it. Now it's all out of whack. Up. Double check. So this, as long as we're engaged, and we're good, and we're touching this snug, we are, and that should be the right distance. Yeah, this has got to be changed. Of course, it never goes like it does on camera. I mean, off camera. And we'll double check this distance. Double check. Double check this. Okay, this has to go back a little bit. So all I had to do was loosen it so that this thing would come up flush, and then tighten it down. Now I'm checking all the way along the length to make sure it's the same distance from the factory edge all the way across, and it is. So now what we should be able to do is use this as our guide reference, and then we should be able to pull the motor backwards and forwards all the way to engage the thing. Now, one thing we do as a final check is we take this off just to make sure this all hits flush, and it does. And let's just see from this side. The alignment is very, very good. So then what we're going to do is we're now going to put 3 screws, number 6 screws. We're going to drill and put 3 number 6 screws in to hold this down. And then what we're going to do is we're going to put another one on the other side. Then what we're going to do is we're going to put screws with washers into this to hold this in position where we want it for any particular experiment. Okay, so these tracks are going to hold our equipment group in that location. Now, one thing I probably didn't show you in the beginning, and I should have, is I'm doing this off the edge of the table, and to keep it from falling over the edge, I've actually clamped this to the table over here so that it doesn't fall off the table. Okay, once you've fastened down all 4 tracks, you can remove the center board. Now, when you apply the other tracks, you don't have to go through the alignment process. Just get another sheet of AZAC and just use that as a spacer, and then you can line up the other 2 rails without having to go through that alignment process, because what you're going to do is transfer the alignment of the rail you did all the alignment onto the other side. Okay, once you pull out the center board, slide the 2 assemblies up against each other, and there's a shadow in there which is making it look a little off. But that is perfectly aligned. It's hard to see in the camera. It looks a little off because of the shadow. And I don't have these things perfectly on. Okay, but without the shadow there, it's perfectly aligned. Okay, next take your center board over to a different work surface, a work surface that has an ability to take your drill bit without breaking your drill bit and lay down, or push your drill bit all the way through. Then put your alignment plate back on. Then take your ring holder assembly with the ring and put it over the alignment plate. Okay, and then it's not perfectly on, but I'm not going to waste camera time getting it on perfect because I'm just demonstrating what you do. Okay, then what you do is you go through and mark all the holes, and then you drill the holes, and then I'll show you what to do next in a second. Okay, once you get done cutting the holes, get yourself a compass, put it in the alignment hole, and go out to as close to the hole, pretty close to the hole is good. Okay, and that's the hole you're going to cut out with a jigsaw. Now, there's a lot of clearance between where the rail is, but that's okay. With as much area in there you can as possible is going to make it easier to swap out magnets from the back side. So you don't have to go perfectly to the hole, but as long as you're much far away from the inner edge. That's why I made this wider than the previous, to get more clearance on the inside between the holes and the ring. This doesn't have the ring in it right now. All right, this ends the Paradox generator build. The reason why we're shutting down early today, and well, we've been shutting down every single day at around late afternoon, because the thunderstorms come up. It's a weird freak occurrence. Usually this happens at the end of August. It's now been happening at the beginning of July, which is now, is thunderstorms rolling in toward evening. And one night they lasted almost 6 hours. And I've already lost 2 security cameras and a weather station from the lightning. That's how bad it is up here. So when the thunderstorms come rolling in, I basically shut off all of the power strips and all of the equipment, all the computers, everything, and just have a beer till it's over. Unfortunately, one night it lasted 6 hours. So we're going to start up again, and we're going to do part 2 of the build, and part 3 we'll probably take some of our first measurements.